So now we've looked at percentage composition, we can now calculate empirical and molecular formula. We've already had a look at the molecular formula, so we're also going to learn a bit more about empirical formula in today's lesson. So formulas. So percentage composition from the last lesson allows you to calculate the simplest ratio amongst the atoms found in the compound. So an empirical formula is the formula of the compound that expresses the lowest whole number ratio of the atoms. Whereas the molecular formula is the actual formula of the compound showing the actual numbers of atoms present. Okay, so for example, you could have H2O2 would be the molecular formula, whereas the empirical formula would be OH, because if you divide both hydrogen atom number and oxygen atom number by 2, you'd end up with 1. So here's another example. You've got C4H10. That's the molecular formula, whereas the empirical formula would be C2H5. Or C6H12O6 would be the molecular formula, and CH2O would be the empirical, the smallest ratio of the atoms in the molecule. So is H2O2 an empirical or a molecular formula? I kind of gave it away in the last slide. So it's a molecular formula, as it can be reduced to OH, which is the, or HO, which is the empirical formula. Okay, so now we look at how to calculate an empirical formula. An oxide of aluminium is formed by the reaction of 4.15 grams of aluminium and 3.69 grams of oxygen. So our job is to calculate the empirical formula. So the first thing you have to do is determine the number of grams in each element of the compound. For this question, it's pretty straightforward. You've got 4.15 grams of aluminium and 3.69 grams of oxygen. You then have to convert these masses into moles. Now remember the equation, number of moles equals the mass over the molar mass. So you've got 4.15 grams of aluminium, you're dividing it by the atomic mass, molar mass, which is 26.98 grams per mole, to give 0.1539 moles of aluminium. Correspondingly for oxygen, 3.692 grams of oxygen divided by the molar mass of oxygen, which is 16, gives 0.2308 moles of oxygen using the equations that we have here. Okay, so continuing on, step 3, find a ratio by dividing each element by the smallest number of moles. So our smallest number of moles is going to be 0.1539. So we 0.1539 divided by 0.139 gives 1 mole of aluminium, and 0.23 is larger, so you divide it by the smallest, so it'll be 0.23 divided by 0.15 for oxygen to give a ratio of 1 to 1.5 ratios. Okay, so obviously you can't have half an atom of oxygen, so what you're going to have to do is multiply by a common factor to get a whole number, and it's going to be 2, of course. So it'll be 1.5 times 2 gives 3, and 1 times 2 gives 2 for aluminium. So the formula, therefore, will be Al2O3. Okay, so here's another example which you can practice calculating an empirical formula. So now we have a 4.55 gram sample of cobalt. It reacts with 4.47 grams of chlorine to form a binary compound. Determine the empirical formula for this compound. So pause the video now, and then we'll go through the answers and see if you're on the right track. Okay, so welcome back. So the first step you have to do is you have to find the masses of each of the atoms involved, elements involved. So you first have, from the question, 4.55 grams of cobalt, okay, and then you convert that to moles by dividing by the atomic mass of cobalt, which is 58.93, which gives 0.07721 moles of cobalt. You then do this for chlorine, so you've got 4.475 grams of chlorine, divide it by 35.45, the relative atomic mass, and then you get 0.1544 moles of chlorine. And you can clearly see that this is the smaller number, So you should be dividing by that smaller number for the next step. So for cobalt, it'll be 0.077 divided by 0.77 to give 1 atom of cobalt, and 0.154 divided by 0.77 to give 2 atoms of chlorine. So the formula will be, the empirical formula will be cobalt dichloride. Cobalt chloride's formula, cobalt chloride. There we go. Okay, next one. So you've got 2 grams of iron this time, and it's heated in air and reacts with oxygen to find a final mass of 2.57. Determine the empirical formula. So again, pause the video and see if you can find an answer before starting the video again and checking it. Right, so again, the mass of iron is 2, and the mass of oxygen will be this time 2.57. 3 minus 2, because there's no, remember the conservation of mass, so the amount of oxygen has to be in the final product, so it must mean that the amount of oxygen is going to be 0.573 grams. So you found the mass of both the iron and the oxygen. Next thing to do is you've got to go from mass to moles. So you're going to have 2 divided by 55.85 to give 0.0358 moles of iron, and corresponding for oxygen, you've got 0.573 divided by 16 to give 0.358 moles of iron. You can clearly see that there's no smaller number per se. So you can choose either one of those. So it means that it must be a 1-to-1 ratio, so the formula must be FeO. So hopefully you got that correct. If not, rewind the video, see where you went wrong. If not, if you still can't understand it, then come and see me. Okay, so the next one's a slightly more complicated empirical formula question. So here we have a sample of lead arsenate with the following masses of lead, hydrogen, arsenic, and oxygen. Your job is to calculate the empirical formula of this insecticide. So pause the video now and come back once you think you've got an answer. Okay, so welcome back. So the first thing we have to do is go and work out the masses of each. Well, it's already in the question, so that first step's done. Next step is converting the masses to moles using number of moles equals mass over the molar mass. So that's what we'll do here. So you end up with 0.00667 moles of lead, the same amount of hydrogen and arsenic, and 0.02667. So these guys here are obviously the smallest. This is the biggest. So you will be dividing to find the ratio, you're dividing by this number all the atoms. So let's do that. So it means you end up with 1 mole of lead, 1 mole of hydrogen, 1 mole of arsenic, and 4 moles of oxygen. So it means that the empirical formula must be lead, hydrogen, arsenic, tetraoxide. So 4 oxygens. So hopefully you got that correct. There we go. Next question. Lots of questions. Practice makes perfect. The most common form of nylon is 63.38% carbon, 12.38% nitrogen, 9.8% hydrogen, and 14.14% oxygen. Calculate this time the empirical formula of nylon 6. So this time you're given the percentages. So now you've got to try and find a way to get from these percentages into an empirical formula. A bit tricky. So pause the video now and we'll go through the answers once you have an answer for yourself to check against. Okay, so welcome back. So how are we going to convert these percentages into masses? Well, that's what we're going to try and do, work out the masses. So the way I would do it is I would say that I would predict we have 100 grams of the substance. Therefore, you'd have 63.38 grams of carbon, etc. Let's see how to do it. Okay, so what you do is you say you have 100 grams of nylon 6. Therefore, the masses of the elements present will be 63.38 grams of carbon, 12.38 grams of nitrogen, 9.8 grams of hydrogen, and 14.14 grams of oxygen. So we have a mass. So then we go from mass to mole, using the equation number of moles equals mass over mR. So you end up with 5.3 moles of carbon, 0.8837 moles of nitrogen, 9.72 moles of hydrogen, and 0.8832 moles of oxygen. And you can see, just barely, that this is the smallest number. So you should divide all these numbers by that smallest number as the next step, which we'll do in the next slide. Okay, so step 3, divide by the smallest. So we end up with 6 moles of carbon, 1 mole of nitrogen, 11 moles of hydrogen, and 1 mole of oxygen. Therefore, the empirical formula, at least for nylon, is going to be 6, 1 to 11 to 1, or C6, NH11, O. Bit of a harder question. Okay, your first experience with the percentages. So hopefully you got that right. If not, you can see how you can get it right by going back through the steps. So we've looked at an empirical formula and how to calculate it. So the next step is to calculate the molecular formula. So here's the example. A white powder is analysed and found to have an empirical formula of P2O5. The compound has a molar mass of 283.88 grams per mole. What is the compound's molecular formula? So the first thing we have to do is work out the molar mass of the empirical formula. So it's going to be 2 times phosphorus, so it's 2 times the atomic mass of phosphorus, which is 30.97, giving 61.94 grams per mole, and then work out the amount of oxygen, so it's going to be 5 times 16, which is 16 being the atomic mass of oxygen, which gives 80. Find the sum, and it's going to have an empirical formula. The molar mass will be 141.94. Now notice that that number does not match with that number, so what you have to do is then divide the molar mass of the empirical formula by divide the molar mass that you're given in the question by the empirical formula mass to give a ratio of 2. And it's a matter of just multiplying the empirical formula by 2, so 2 times 2 is 4, 5 times 2 is 10, so the formula should be P4O10. Okay, this is ones for you. A compound has an experimental molar value, or molar mass, of 78 grams per mole. The empirical formula is CH. What is its molecular formula? So pause the video now, try and work it out, come back when you have an answer, and then we'll compare to see if you're on the right track. Okay, so welcome back. So the first thing you have to do is work out the empirical formula's mass. So it'll be 12 plus 1 to give 13 grams per mole, and then find the ratio between the experimental mass and the molar mass. So it'll be 78 divided by 13 giving 6. So it's going to be CH, so you've got to multiply the number of carbons by 6 and the hydrogens by 6 to give a formula, a molecular formula of C6H6. Okay, another example. To find the empirical formula for a compound that was found to contain 80% carbon and 20% hydrogen. A little bit harder, but let's have a go. Pause the video now and see if you can work it out. Okay, so again, you're thinking maybe it's going to be out of 100 grams again, isn't it? Just like the empirical formula case. So the first thing you have to do is convert each of those percentages to grams. So we'll call it 80 grams carbon, 20 grams hydrogen. So divide each by its atomic mass. So it will be 80 divided by 12 gives 6.666 for carbon and 20 for hydrogen. Notice there's a ratio coming now. Step 3, what's the smallest number? It's going to be the one for carbon, which is 6.67. Now divide each of these numbers by the smallest number, so 6.67 divided by 6.77 is going to be 1, and 20 divided by 6.67 is going to be 3. So it means that the empirical formula is just CH3, a methyl group. Okay, so hopefully you got that right. Next question. Now find the molecular formula, since we've just done the example, of a compound that has been found to contain 80% carbon and 20% hydrogen. So now we've got the molecular formula, and it's got a molar mass this time of 30. So we know it's CH3 is the empirical formula. So pause the video now and come back once you think you have an answer. Okay, welcome back. So again, now we have the empirical formula you just found, which is CH3, and follow the method. Divide your given molar mass by the molar mass of the empirical formula, which you know it's 3 times 1 plus 12, 15. So it's going to be 30 divided by 15 to give 2, which is your common ratio. Then you multiply your formula by 2 to give C2H6. And that's the answer. Next question. A compound was found to have a percentage composition of 2% hydrogen, 32.7% sulfur, and 65.3% oxygen. Find the empirical formula. So pause the video now, see if you can find an answer just like before, and come back when you think you have one. Right, welcome back. Right. So the final question is, a compound is found to have a percentage composition of 2% hydrogen, 32% sulfur, or 32.7% sulfur, 65.3% oxygen. So your job is to find the empirical formula. So pause the video now and come back when you have an answer. Okay, so the first thing you have to do is you have to convert these to masses, these percentages. So just say it's going to be 100 grams. So you end up with 2 grams of hydrogen, 32.7 grams of sulfur, and 65.3 grams of oxygen. Then you've got to convert to moles. So it's mass to mole. So it's number of moles equals mass of the molar mass. So it's going to be 2 divided by 1, 32.7 divided by 32, and 65.3 divided by 16 to give 2, 1.02, and 4.08 respectively of each of the moles. 1.02 is the smallest number. You divide each of the others by that smallest number to give a ratio of around about 2 to 1 to 4. So that means that your formula should be, in the end, and I'll use green, it should be H2, oh, green I said, there you go, H2SO4, sulfuric acid, which is the answer. Just so happens that it's the same molecular formula. Okay, and that is the answer for the last question. So hopefully you got that right. If not, as before, go through your notes, go through the videos, and if you still don't understand it, come and see me.